All right, on your quiz on Monday, saying we're doing a 3.5 wrap-up. It's due at the end of class, so I'm doing it with you. On your quiz on Monday, you're going to have 6 questions. 4 of them are going to be like these first few, and then 2 are going to be, given the zeros, you have to write the polynomial function. They're kind of long, so. You'll get your review tomorrow. You guys can work on it and ask questions tomorrow in class. Friday, I will have a video working the entire review out, and then Monday will be your quiz. That's going to be our last quiz for the quarter. Your test review for the midterm will also be published on Friday. It needs to be done by Tuesday. So, in the meantime, between Friday and Tuesday, that midterm review needs to be done. You're going to turn it in, then we're going to go over it.
This week?
Huh?
This Friday and Tuesday?
Mm-hmm. Yeah. All right, so look, guys, if you have questions on your quiz like this, where you're finding the roots, finding the zeros, solving, the directions will say something like, number 1 might say, find all of the roots. Number 2 might say, find all the real roots. Zeros, same question. Excuse me? It might say, find the rational roots. You need to understand what those words mean. It will not have all of these things listed and you have to write everything. I just want you to understand what that means. If you have rational versus irrational, both of these things are real, meaning there's no I's in it. The easiest way to remember this is real, we'll say is pretty, and irrational is not pretty. Think about this. If someone is acting irrationally, it's not a pretty sight, right? Pretty meaning it's a whole number. Pretty meaning it's a fraction that terminates. Meaning if I said to you guys, where on the x-axis is 3/2, you'd be able to take your finger and put it right on it, right? You know where 3/2 is, 1.5. If an irrational is, it's say square root of 7. Do you guys know exactly what square root of 7 is? No, you know, kinda. But an irrational number is one of those decimals that just goes on forever and ever and ever, like pi. So a real,
A quarter, like 3/4?
Yep, 3/4, that's fine, because it terminates. It'd be 0.25. Yep, you'd know exactly where it was. But the square root of 2, the square root of 11, square root of 33, if we cannot figure out the exact value for it, that would be irrational. Now, an imaginary has what in the answer? An I. All right? And if I ask for all of the zeros, that means everything. The pretty ones, the not pretty ones, and the imaginaries, okay? So just understand the difference between the directions that could be asked. It's not going to be listed out like that. It's going to say find all, find the imaginaries, find the rationals, that sort of thing. So let's go through all of these, and we'll talk about each of the answers that we find. You guys should get in the habit of looking at this and saying from the beginning, okay, how many answers for this problem should I have?
5.
How do you know you have 5?
This is the highest.
The highest exponent is 5. Now, are all of them going to be pretty? No. Are all of them going to be real? Maybe, maybe not. But you know at the end of the day, the end of your problem, you should have 5 answers. So the first thing we look for is a GCF. Guys, don't get confused. I see 3 terms here. Can I use the quadratic formula to solve this? No. You can only use the quadratic formula when your highest exponent is what? 2, x squared. So if I look at this, do I have anything in common that I can take out of all 3 of these? Okay, take out an x. You'd be left with x to the 4th plus 5x squared minus 14 equals 0. Finding the roots, the solutions, the zeros, all that stuff means what does x equal? So now in the middle here, in the parenthesis, I am left with a trinomial. If nothing works, we go to P over Q. But let's think about this for a second. A trinomial, can I break this down? What times what would give me x to the 4th? X squared and x squared, right? Are there factors of negative 14 that'll multiply to give me negative 14 but add to give me 5?
7 negative 2.
Plus 7 minus 2. Very good. Now you look to see, can I factor any more? With what's left over, do I have the difference of perfect squares? Meaning, I have a minus sign in the middle, and both the x and the number are perfect squares. Do I have that? No. So then I just take each piece and I set it equal to what? To 0. And then we solve. X equals 0. Is that an okay answer? Are we allowed to have that? Yeah, absolutely. Do you know exactly where x equals 0 is on the x-axis?
Yeah.
Yep, that's a real, rational number. This is real and rational. All right, x squared plus 7. Well, to solve this, I have to move 7 to the other side, right? So this becomes x squared equals what? Negative 7. Good. How do I solve this? Take the square root. Guys, when you take the square root, what goes in front of your answer? Plus and minus. Now think about this. Do you know the square root of 7? No. Can you break it down? No. So this square root of 7 stays inside. But what comes out? Y and I. Because that is negative. Good. So I have two solutions here. What kind of solutions are those?
Imaginary.
These are imaginary. Good. So now I move to the last bit and I say, okay, I'm going to take this negative 2, scoot it over here. So x squared equals 2. What do? Take the square root. What goes in front of my answer? Plus or minus. Guys, what is the square root of 2? There is one, but is it gross?
Yes.
Yeah. It's not 2. The square root of 2, that's just going to stay underneath your radical right there. This is real, but is it pretty? No, this is an irrational. So if this question, if the direction said find all of the roots, how many answers would you have? 5. If it said find all of the real roots, how many would you have? 3. Good. I have 1 rational, 2 irrational. If it said find all the imaginary, how many? 2. You need to understand the difference between those 5 answers. Everybody, you okay with that? All right? All right, make sure you're following along, guys. This is due at the end of the period. This is like a free 100. If you do not turn it in before the due date and time, it's a 0. I'm not taking anything late. All right, look at number 2. All right, go through the motions. First things first, I'm going to say, yeah. It'd be all 5 of the answers. Yeah. You don't have to put anything here. You don't have to put anything there. I want you guys to understand that each 0 could fall into a different category. That there's different categories is what I'm trying to show you. All right, let's look at whatever I write down is what I need to see. Look at number 2. First thing I like to do is say, okay, how many answers at the end should I have? 3. I don't know what types they will be, but I want 3. Is there a GCF that I can take out? No. Can I group this? No. Please and thank you. Nope, it's not going to group. All right, so what do we do when nothing works? What's the only thing that will work? P over Q. You take the factors, plus and minus, of the last number. 1, 2, 3, 4, 6, 8, 12, 24. There's a lot, 24. Now, I can assure you, everything on the quiz will work out. I'm not going to give you any that are not factorable at all. Meaning, you do, God bless you, synthetic division 12 times and nothing works. Something will always work to give you a remainder of 0. It may not be the first thing that you choose, but they will all work out. So let's just start with 1. Positive 1. And Jad, I know this is a refresher, but we're trying to find where the remainder is 0. That means it's a factor. Shush. So I have 1, 5, negative 2, negative 24. We're going to use synthetic division to find a remainder of 0. So take your time, bring down that first factor or term. 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. Negative 2 and 6 is 4. 4 times 1, is this going to work? No, don't waste your time. Go to the next factor. So I'm going to try negative 1. 1, 5, negative 2, negative 24. Bring down your 1. 1 times negative 1 is negative 1. 5 and negative 1 is 4. 4 times negative 1, negative 4. Negative 2, negative 4, negative 6. Is this going to work? Nope. All right, go to the next one. Let's try 2. 1, 5, negative 2, negative 24. Bring down the 1. 1 times 2 is 2. 5 plus 2 is 7. 7 times 2 is 14. Negative 2 of 14 is 12. 12 times 2 is 24. What's negative 24, positive 24? 0. So what did you just prove to me? X equals 2. That is a factor. That is a 0. That is a solution. That's a root. X equals 2. Now, what you have left over is your resulting polynomial. So x squared plus 7x plus 12 equals 0. At this point, if you wanted to just use the quadratic formula, could you? Yes. But before you do that, I would try and see if it factors. Will this factor? What times what will give you a positive 12 when you multiply, but a positive 7 when you add?
4 and 3.
Perfect. X plus 4, x plus 3. So I have x equals negative 4, and I have x equals 3. How many answers at the beginning did we say we were going to have?
3.
3. Oh, my bad. Thank you. How many answers did we say we were going to have? 3. It should be negative. I just didn't write it. How many answers do we have? 3. What do we notice about all 3 of these answers? They're all real and they're all rational. Good. Rational because they're pretty. I know exactly where they are in the x-axis. All right, we good? This is really good practice, guys. All right, look here. This wouldn't be here normally. It shouldn't be there. All right, go ahead. Can we just factor this? This looks a little weird. What's wrong with it? There's a 12 on the other side. So what do? Do we just cross it out and be like, man, we can't do this one? No, we just move it over. I need to get everything on one side. So this is x cubed minus 7x squared plus 16x minus 12 equals 0. There's no GCF, so, oh, please, is this going to group? No. Oh, Mrs. Meadows. Good question. If I take out x squared, I'm left with x minus 7, right? What do they have in common with 16x and negative 12? I could take out a 4, right? Plus 4, and I'd be left with 4x minus 3. In order to group, when you take out, these two parentheses have to be the same. So since they're not, mathematically, that doesn't work out. So we have to say, oh, geez, since I'm left with x cubed minus 7x squared plus 16x minus 12, I have to use what?
P over Q.
P over Q. That means I take the factors of the last number. Again, it's 12. So 1, 2, 3, 4, 6, and 12. And we're just going to do synthetic division till we get a remainder of 0. Good. So let's start with 1. Let's just try 1. I have 1, negative 7, 16, and negative 12. Yeah? So I bring down 1. 1 times 1 is 1. Negative 7 and 1 is negative 6. Negative 6 and 1 is negative 6. 16 minus 6 is 10. Ugh, is this going to work? No. All right, go to negative 1. Guys, just don't assume that 1 and negative 1 don't ever work, because they do. Just happens to be in these two that they don't. So bring down your 1. 1 times negative 1 is negative 1. Negative 7 and negative 1 is negative 8. Negative 8 and negative 1 is 8. Is this going to work?
No.
Right? Because 16 plus 8 is going to give me 24. That's not going to give me a remainder of 0. So let's try 2. 1, negative 7, 16, negative 12. Like I told you guys at the beginning, I promise you synthetic division will work in all of these problems. I'm not going to give you any that aren't factorable. So don't give up. Don't get frustrated. 1 times 2 is 2. Negative 7 and 2 is negative 5. Negative 5 and 2 is negative 10. What's 16 minus 10? 6. What's 6 times 2? What's negative 12 and 12? Yay! What do we find? X equals 2. Perfect. And then what we have left over, we hope, factors pretty. If it doesn't, at this point, since we're x squared, we would go ahead and have to use the quadratic formula. So, ladies and gents, are there factors of 6 that multiply to give me a positive 6, but add to give me a negative 5?
Negative 3, negative 2.
Yes, x minus 3 and x minus 2. Some people last period are like, well, 6 and 1 works. Guys, I get that 6 times 1 is 6, and 6 minus, or 1, negative 6 plus 1 is negative 5. But in order to get a multiplication answer that is positive, they either both have to be negative or both positive. So that's why 3 and 2 would have to be your answer here. So my other x values are x equals 3 and x equals 2. I have 2 twice. Is that possible?
Yeah.
What does that mean? Multiplicity.
Wait, can you repeat that for 6 and then 1?
Uh-huh. Because these are all real and rational. Because I want a positive 6 when I multiply, the factors that you multiply have to be both positive or both negative.
Right.
Yeah. That's a tricky one. A lot of times that gets people thrown off. Thrown off a little bit.
So then if you were asked to write all the rational reals, you would just write x equals 2 and x equals 3?
Mm-hmm.
Or you would just write them twice?
It doesn't matter. You could write it twice or you could write it once. It doesn't matter. All right, you guys are doing a great job. Let's move along here. Again, this one looks a little weird. How can we fix it? We can solve all of these. How can we fix this? We're going to move 75 where? To the left side. We're going to add it. So I have x to the 4th plus 20x squared plus 75 equals 0. All right, first thing we look for is a GCF. We don't have one. But this is a trinomial. Let's see if we can factor this. What times what would give me x to the 4th? Okay, x squared. Now I'm trying to find a 20. Excuse me, when I add factors of 75. So I have 1 and 75. That's not going to add to give me 20. 2 and nothing. 3 and 25. That's not going to work. What about, Gombar, what'd you say?
15 and 5.
5 times 15 is 75. 5 plus 15 is?
20.
Perfect. So plus 5 and plus 15. Check to see if you can factor any more. Do you have the difference of perfect squares? No. So we just have to say, all right, well, x squared plus 5 equals 0, and x squared plus 15 equals 0. Move 5 to the other side. I get x squared equals negative 5. Right now, what do I know my answer is going to be? What kind? Why? Because there's going to be a negative underneath the square root. Great. So I have x equals plus minus. Do you guys know the square root of 5? Is there a perfect square inside of 5 that we could break down? Yeah, you're going to pull the I out. But can I break 5 into anything? No. So it's just going to stay underneath the square root. And again, guys, perfect. You're going to take that I out because the radical has a negative inside. So I have 2 answers here, and they're both what? Imaginary. Very good. So now I'm going to come over and do the same thing here. I'm going to move 15 over. X squared equals negative 15. Take the square root. So x equals plus minus goes in front. Anybody know the square root of 15? Is there a perfect square inside of it that we could break down? No. So it's just going to say square root of 15. But what needs to come out in front? I. Guys, don't put the I behind it because then it looks like it's underneath. So I have 2 more answers here. Again, I should have had 4 at the beginning because it was x to the 4th. What do you notice about these 2 answers? They're also imaginary. So if you had a question like this and it said, tell me all of the rational roots, there are none. Tell me all of the real roots, there are none. If I said, tell me all of the roots, then you would answer with those 4. But remember, rational and irrational are real numbers. They don't have I's in them. All right, let's look at this last one. This one's a doozy. This was on WebAssign. Some of you might have had this exact problem or something like it. How many answers should I have for this?
5.
I should have 5. Guys, we don't know any other method to factor when we have x to the 5th other than what? P over Q, right? I have 54. It's a big number. So I got to write all the factors of 54. 1, 2, 3, 4, 5, 6, 6, 9, 18, 27, 54. If you don't know them, can't do it in your head, that's fine. You have pen and paper, write it down. How do you know that 3 goes into 54? Adam, what's 5 and 4? 9? If 3 goes into 9, then 3 goes into 54. So again, start with 1. Don't just jump around. Let's hope 1 works. 1, negative 4, negative 8, 42, negative 9, negative 54. This is a long one, I know. Bring down the 1. 1 times 1 is 1. Negative 4 and 1 is negative 3. Negative 3 and 1 is negative 3. Negative 8, negative 3 is negative 11. Negative 11 and 1 is negative 11. It's 42 minus 11. 31. 31 times 1 is 31. Is this going to give me negative 54 to cancel out? No. Let's just go to negative 1. So 1, negative 4, negative 8, 42, negative 9, negative 54. 1 times negative 1 is negative 1. Negative 4, negative 1 is negative 5. Negative 5 and negative 1 is negative 5. No, it's not. It's positive 5. Sorry. Negative 8 and 5 is negative 3. Negative 3 and negative 1 is 3. What's 42 and 3? 45. What's 45 times negative 1? Negative 45. Hey, guys, what's negative 9 and negative 45? Negative 54. What's negative 54 and a negative 1? Positive 54. So what did you just prove here? X equals negative 1 works. It is a factor. X equals negative 1 works. So what do I do with this junk that's left over? This is my resulting polynomial. X to the 4th minus 4x cubed minus 3x squared plus 45 minus 54 equals 0. Again, we don't have any way to solve this other than what? Yes, sir. Say it again. Oops, thank you. We have no other way to solve this other than what? P over Q. And that darn 54 is the last number again. So I'm going to do it over here so we have some room. What was it again? X to the 4th. Minus 5 minus 3. So minus 5x cubed minus 3x squared. Is it plus 45x? Minus 54? Okay. So plus minus 1, 2, 3, 6, 9, 18, 27, 54. Again, I know this is long, but I promise it'll work. So let's do our synthetic division. I'm going to start with 1. 1, negative 5, negative 3, 45, negative 54. Number 5. So bring down your 1. 1 times 1 is 1. Negative 5 and 1 is negative 4. Negative 4 and 1 is negative 4. Negative 3 and negative 4 is negative 7. Is 45 minus 7 somehow going to give me something to cancel out negative 54? No. So move along. 1, negative 5, negative 3, 45, negative 54. 1 times negative 1, negative 1. Negative 5 and negative 1, negative 6. Negative 6 and negative 1 is 6. Negative 3 and 6 is 3. 3 times negative 1 is negative 3. 40. Is this going to work? All right, try 2. Again, don't give up. Don't tell me that something is wrong. Just check your math or keep plugging along. You will find it. 1 times 2 is 2. Negative 5 and 2 is negative 3. Negative 3 and 2 is negative 6. Negative 3 and negative 6 is negative 9. What's negative 9 times 2? What's 45 minus 18? Hold on. What's 45 minus 18? You guys are going to have to do a little work. It's 27. Well, what's 27 times 2, guys? 54. What's a negative 54 and a positive 54? What did you just prove? X equals 2. So you found another one of your x values. You had x equals negative 1. Now I found x equals negative 2. Good. Yep. What is my resulting polynomial right here? I found 2 of my answers. I still have 3 hidden. This is x cubed minus 3x squared minus 9x plus 27 equals 0. Now at this point, there's no GCF, but we are starting to find that, oh wait, there's something else we can try here. Let's try and group it. Before we do P over Q again, which you could. If you're comfortable doing that, go ahead. You want to keep doing P over Q if you need to until you get to x squared. Then you use the quadratic formula if you don't want to try something else. But let's see if we can factor this. Is there something in common between x cubed and x squared?
Yeah.
X squared, right? So I'm left with x minus 3. Can I take anything out of negative 9x and a positive 27?
Negative 9.
Negative 9, good. So that leaves me with x minus 3. Have I discovered a new GCF? What is it? X minus 3. They both have an x minus 3. That means I take that out in front, I write it one time, and what happens to my leftovers? X squared minus 9 equals 0. Can I factor that a tad bit more?
Yeah.
To what? I have x minus 3 here out in front. Then this becomes x plus 3 and x minus 3. So I uncovered the last 3 zeros. They happen to be x equals 3, x equals negative 3, and x equals 3. Do I now have all 5 of my answers?
Yeah.
Yes. I have x equals positive 3, negative 3, positive 3, negative 2, and negative 1. All 5 of those are what kind of numbers? They're all real. They're all reals, all rationals. Good. Everybody with me? Okay, so 4 of your 6 questions are going to resemble those problems. Then you're going to have 2 that are like these last ones. If you notice the directions, it says given the zeros, given the answers, write your polynomial in function notation. That means at the beginning you should have f of x equals g of x equals h of x equals p of x equals, I don't care, but it needs to be in function notation. So all this problem is here are the 3 answers. What did the original polynomial look like? So the way we do that is we're going to work backwards. I know I have 3 parentheses because I have 3 answers. When I take positive 7 and move it over here, my parenthesis says x minus 7. When I take negative 2 and move it over here, my parenthesis says x plus 2. And when I take 1 and move it over here, my parenthesis is x minus 1. Everybody with me?
Yeah.
And now we FOIL. I'm going to leave x minus 7 out here by itself for a minute. I'm going to FOIL these 2 together. So x times x is x squared. X times negative 1 is minus x. 2 times x is 2x. And 2 times negative 1 is minus 2. Still have my x minus 7 hanging out here. Let's combine like terms. I have x squared plus x minus 2. And now we just multiply again. X times x squared is x cubed. X times x is x squared. X times negative 2 is minus 2x. Negative 7 and x squared is minus 7x squared. Negative 7 and x is minus 7x. And negative 7 and negative 2 is plus 14. So your final answer in function notation, f of x, g of x, h of x, whatever. Function notation, then you have x cubed. Combine your like terms. So I have x squared and a negative 7x squared gives me negative 6x squared. Negative 2x and a negative 7x gives me negative 9x. Then what? Plus 14. And that is your final answer. You're given the answers, and you guys are going to determine the original, God bless you, polynomial. All right, now if we scoot over to number 7, what's up?
Can you get it?
Yep. All right, number 7's a little different. I did this one on purpose. How many answers do I have here? 3. So my original polynomial should be x cubed. When I write x equals 0, you guys can write x plus 0 or x minus 0. It doesn't matter because there's no sign on 0. And then I have this would be x plus 6, and this would be x minus 8, right?
Yeah.
All right, I'm going to leave the x plus 0 out in front. Yeah. Uh-huh. Okay, because if you move this over, you could write x plus 0 or x minus 0. It doesn't matter. But I'm going to show you a little shortcut here. I'm going to leave the x plus 0 out in front here. And I'm going to FOIL the second two. So x times x is x squared. X times 8, negative 8x. 6 and x is plus 6x. 6 and negative 8 is minus 48, right? So if you're x plus 0, and then I have x squared minus 2x minus 48. Agreed?
Can we just distribute the x by itself?
Now, if I take this and I distribute the x, this becomes x cubed minus 2x squared minus 48x, right? Guys, what's going to happen when I multiply everything by the 0? What's 0 times x squared? So 0. 0 times 2x is 0. And then 0 times 48 is 0, right? So do I really have to put x plus or minus 0? No. When you guys go to do this, you can just leave the x out in front like this and just FOIL it that way. Because this is what you would end up with right here. Because when you distribute a 0, all you're doing is multiplying everything by 0. It goes away. If you want to write it in a parenthesis like that and distribute, that's fine. But that only happens when you have x equals 0. Any other number, obviously you have to distribute it. But if you just have x equals 0, just leave it. It's fine. All right, 2 more, and then we're done. I'm going to do 9, just because it's right underneath. This problem, the only thing that makes it a little more difficult is you just have bigger numbers. But I have 3 answers. My 3 answers are 5/4, 2/3, and negative 1/2. So when I write x, this becomes minus 5/4. This becomes minus 2/3. This becomes plus 1/2. Do not go through and distribute, multiply, and FOIL fractions. How would I make this denominator go away? My denominator becomes my what? Coefficient. So 4x minus 5, 3x minus 2, and 2x plus 1. And now we FOIL. Does not matter if you want to do 4x minus 5 times 2x plus 1. I just always leave whatever's out in front, hanging out in front, and I deal with the second two. So 3x times 2x is 6x squared. 3x times 1 plus 3x. Negative 2 times 2x is minus 2x. Negative 2 and 1 is minus 2.
Minus 4.
Minus 4.
Oh, here?
Yeah.
Yeah, I don't know why I wrote that. Thank you. So 4x minus 5, and then clean this up. 6x squared minus x minus 2, right? Now we just do it again. Your numbers might get a little yucky. That's okay. First term's everything behind. So 4 times 6 is 24, x squared. 4 and negative 1 is just negative 4x.
It's cubed, isn't it?
Ay. What am I doing here? Yep, squared. The cubed then squared, sorry. And then 4x and negative 2 is negative 8x. Negative 5 and 6x squared is negative 30x squared. Negative 5 and negative x is plus 5x. Negative 5 and negative 2 is plus 10. So my answer should start off in function notation. I'm going to say g of x this time. Want to use the same letter every time? Perfectly fine. But 24x to the third. Do I have anything else that's cubed? No. So now we combine negative 4x squared and the negative 30x squared is negative 34x squared. Negative 8x and a positive 5x is minus 3x plus 10. And there, ladies and gents, is your final answer. That is your polynomial. I'm going to give you the answers, and you tell me what the original polynomial looked like. Has to be in function notation. All right, let's do the last one. How many answers do I have here?
3.
I have 3. So my parentheses will be x minus 2/5, because when I take this positive over, it becomes negative. X minus 4 and x plus 1/3. Get rid of those denominators. So we have 5x minus 2, x minus 4, and 3x plus 1. I'm going to change it up a little bit. I'm going to put the x minus 4 out in front and deal with that later. I'm going to FOIL 5x minus 2 and 3x plus 1.
No, they're the same answer, right?
I'm just going to do it a little different so you guys can see you get the same thing. So leave my x minus 4 here. 5x times 3x is 15x squared. 5x and 1 is plus 5x. Negative 2 and 3x is minus 6x. And negative 2 and 1 is minus 2. So when we combine like terms, you have 15x squared minus x minus 2. And now we're just going to go through and distribute. X times 15x squared is 15x cubed. X times negative x is negative x squared. X and negative 2 is negative 2x. Negative 4 and 15 is negative 60x squared. Negative 4 and the negative x is plus 4x. And negative 4, negative 2 is plus 8. Everybody with me? All right, write your answer in function notation. P of x equals 15x cubed. Combine your x squareds. What do you have? Minus 61x squared. Combine your x's. Plus 2x. Plus 8. And there, ladies and gents, is your final answer.